Good day, we are the Group 7 and we are here to present to you our research about bamboo leaf ash and corn cob ash as a partial replacement for cement in concrete to reduce organic waste products in landfills.
So, concrete is a known versatile building material that is widely used in construction of roads, buildings, um, infrastructures. Although cement and concrete are often used interchangeably, cement is actually an ingredient of concrete. However, the production of cement is a major contribution of carbon emission. Because of this, we believe that there should be efforts in minimizing the production of cement, and this would mean using alternatives for cement in creating concrete. Moreover, cement is also expensive and hard to acquire, so it is very beneficial to look for better ways in creating concrete without the use of cement.
According to Owolabi, Oladipo, and Popula 2015, the effect of corn cob ash was evaluated as partial replacement for cement and concrete. Corn cobs were collected, air-dried, and burnt to ashes, which were sieved to produce fine ash. Concrete cubes were casted and tested at curing ages of 7, 14, 21, and 28 days by using 0, 5, 10, 15, and 20% replacement levels. The slump test shows that the concrete's workability decreases while the content of the CCA increases. The compressive strength also reduced as the percentage of the CCA replacement increased while interacting with the curing age. The substitution of 0% is used as a control. The findings showed that CCA is appropriate material for use as pozzolan as it fulfilled the minimum requirement of mixed silicon dioxide and aluminum oxide of more than 70%, which should be met by a healthy pozzolan for the production of mixed cement. Based on the result of the test, it was concluded that CCA could be used appropriately in the production of blended cement.
As stated by the Ademola and Buari 2014 in their study, Behavior of Bamboo Leaf Ash Blended Cement Concrete in Sulfates Environment, 0.66 concrete cubes of OPCBLA blended cement are produced measuring 150 mm each side, wherein OPC's partial replacement with BLA range from 0% to 15% in concrete. For 21 days, the specimens were screened and crushed to achieve their congressive strengths, while 28 days were spent curing the specimens on separate media wherein sodium sulfate, calcium sulfate, and magnesium sulfate were utilized at the level of 0.5%, 1.5%, and 2.5%.
The purpose of this research is to produce and determine the effectiveness and the feasibility of bamboo leaf ash and corn cob ash as a partial replacement for the cement in concrete, as it is examined to have a better qualities and its strength and good effect on the environment that might contribute on controlling the amount of discarded organic waste materials. If properly disposed, organic waste causes global and environmental issues. It is the source of a problem in oxygen depletion, pollution, and musty odor. Bamboo leaves and corn cobs considered as an organic waste and is accompanied with harmful problems. It goes through a process on anaerobic decomposition, which produces methane gas when dumped in landfills, which then discharge into our atmosphere. The researchers conducted this to benefit the construction industry, waste disposal, and future researchers. All of the information obtained here could serve as reliable data from trust sources.
To sum it all up, the increase in land pollution has caused a major issue and contributed to climate change wherein we experience disastrous problems like irregular rainfalls, ice caps or glaciers melting, drought, and many more. Organic waste are being dumped in landfills, which also affect global warming, as it releases greenhouse gas methane to the atmosphere, which is 21 times more harmful than carbon dioxide. With the use of corn cob and bamboo leaf, we are trying to lessen this natural and biodegradable waste that will allow us to use it in the construction industry to maintain the waste balance on landfills and protect public and environment's health. It is not only that this study will benefit us to control the waste in landfills and prevent the anaerobic decomposition, but also will have a good effect once these variables are made and partially added to the concrete. In construction, according to the studies presented earlier, corn cob and bamboo leaf ash makes the concrete stronger. And there was a sustainable environmental study that claims a rapid increase in greenhouse gas induces mischievous impact on environment. They stated that the carbon dioxide emission can be reduced to some extent by replacing some amount of cement with corn cob ash. And according to the Guardians in 2019, concrete is the most destructive material on Earth. It also magnifies the extreme weather it shelters us from. Taking in all stages of production, concrete is said to be responsible for 48% of the world's carbon dioxide. Half of concrete's carbon dioxide emissions are created during the manufacture of clinker, the most energy-intensive part of the cement making process. With the increase of waste being disposed in landfills and construction of more infrastructures, more pollutants are entering our land and air. This increase in pollution has contributed to massive decreases on fertile land for agriculture and increase in greenhouse gases that is being trapped on our atmosphere, which contribute to the climate change that we are experiencing right now. If we cannot combat the effect of this, our commercial farming, our freshwater ecosystem, and other supplies will surely diminish. More research and innovations are needed to maintain our clean land and air by supporting and conducting more researches like this. And that would be all. Thank you for listening.